So we've been looking at functions, and recall we looked at a couple of different functions. We looked at these type conversion functions that are built in. So you don't have to import a module or anything. These are just built in for functions in Python. And then we looked at some math functions as well. Those you have to import the math module in order to be able to use them, but they are easily available. Now, of course, when you write programs, you might want other functions, and today we're going to look at how you can write your own functions. But before we do that, just real quickly, we're going to talk about composition, function composition. So recall from our previous discussion about expressions and statements that an expression is just anything that has a value. So if a function returns a value, then a function call must then be an expression, because an expression is anything that has a value. So a function would, if it returns a value, falls into that category. And so a function can be used anywhere that an expression is used. So you're used to the idea of function composition from mathematics courses, like f of g of x, where you take the result of g of x and use it as the argument to f of x. Well, you can do that in programming as well. So, for instance, let's say you're trying to find the hypotenuse of a right triangle. So you could write a statement like this in Python, and this is an example of function composition. So we have this math.square root, so the square root function, okay, and then we're giving it an argument, and the argument is this expression, but this expression has a value, okay, and so the power a raised to the second power, so, and then we add on the power b raised to the second power. So notice these are function calls themselves, and it just returns a value of whatever a squared is, and so that will get added to whatever b squared is. Those will get added together, and that sum will be passed as an argument to the square root function. Okay, so the arguments that you pass to functions don't have to just be, simple variable names or constants. They can be whole entire expressions or function calls themselves, as long as those functions calls result in a return value. You can see another example here where we're sending something to the print function. The argument is whatever sign, okay, of 3 times math.pi divided by 2 is. So you can see here a composition. This is like, this is like your f function, and this is like your g function. So you do g of x, take the result of g of x, and pass it to f of x. Okay, so that will just help you write more concise code rather than writing several statements, like, instead of having to do these separately and adding them together separately and then passing the single parameter. You can just do all of that in the parentheses. All right, so next thing that we want to do is talk about writing our own functions. So how can we add new functions? So far we've only looked at the built-in functions or something that's provided in modules, but you can add your own, and often, like most of the programs that you write in this course, you will be writing your own functions. So a function definition will specify the name of the function, so how you can call it. So the built-in functions have names like int, float, those are the type conversion ones, or the math ones have functions like sin, sin, cos. Okay, well, when you have a function that you write yourself, you have to have a name for yours so that we can know how to call it. So it will specify the name, and then a list of arguments that it needs, and then after that it will specify how to do whatever it is that you want to do in that function. Okay, so for the functions that we've seen, because we didn't define them, we're just using them, I mean, we know what the name is, we know what the list of arguments is, but we have no idea what the sequence of statements is. That's somewhere else in some other file and we can't see it. But when we write our own, we will have to specify the sequence of statements that execute when that function gets called. And the format looks like this. You use the word DEF. That is a reserved word in Python, so it's on that list of, you can't use DEF as a variable because that's part of the Python language, and it's for defining a function. So you put that DEF, and then whatever the name that you want to call the function, and then in parentheses, your list of parameters. This will be all the arguments, this will be placeholders for all the arguments that get passed in. And then you must have a colon. And then on the next line, everything after that has to be tabbed. Okay, so it's very important that there is a tab here. And that is part of the syntax of the Python language, is that you must have a tab there. If you don't have a tab, it won't work correctly. So that game can be a little bit tricky too. If you do, you can run into trouble if you're using spaces instead of tabs, etc. So just make sure that you put a tab there. Okay. This first line where you put the function name and the parameter list, that's called the header. And then all of the statements that come after that, that's the implementation of the function. That's called the body of the function. And there's going to be, like I've just written statements here, there could be several, right? There's going to be, another statement here, another statement. So as many statements as we need, and they all have to be tabbed over after. Okay, so that just keeps going and going until you're done. Okay, so that's the format of what it looks like. Okay. So some of the built-in functions we've seen so far require arguments. Arguments are just the values that get passed into the function when it's called. So for example, when we just said print and then in quotes welcome, remember this is the argument right here. When we do math.sine of math.pi/2, the value that gets calculated by doing math.pi divided by 2 is the argument. Okay. But we could sometimes have more than one argument. So if we were doing combinations of whatever the variable total, the value that's stored for total, taken 4 at a time. So these are arguments. So sometimes you have one argument, sometimes you have two, you could have multiple. I mean, you can have as many arguments as you want, really. Inside the function, the values of the arguments are assigned to variables called parameters. So sometimes I probably abuse the notation. So the arguments are the values that are used when you call the function, and parameters are the variables that are used when you're in the function when you're actually performing the computations. So the arguments get passed in and assigned to the parameters. Okay, so parameters are local to the function, which means they only exist inside the function. So those variables that are named by the function in the heading, those only exist in the function. You can't refer to those variables outside of the function in other functions or in the rest of the program. They're sort of created when you call the function. You use them as long as the function exists, and as soon as you return from the function, those are destroyed. Okay, and so they don't have any life past the function. So they're just called local. So they only exist inside the function and not outside. So one thing that can be tricky when students are beginning to program is sometimes they think that when they're calling a function, that they have to name the arguments that they're passing into a function exactly the same thing as the parameters, and you do not have to. When we type an example and look at that, I'll help you understand that idea. But at least it's good to have this written down that they do not have to have the same name. And just remember that when you call a function, any expression, that anything that has a value can be used as an argument to get passed in as an argument and assigned to a parameter. So we're going to do a little example to make this more concrete, to write a function that gives a personalized greeting using the interactive mode of the Python interpreter. Okay, so let me pull up our Python interpreter. All right, so we know that the format goes like this. We put the keyword def. Okay, notice that it showed up in a different color because it's a keyword. And then with the name that we want to call it, let's just call it greet. Oh, not Gret, but greet. Okay, and then in parentheses, we're going to give the list of our parameters or any variables. So what I'm thinking of is, like, have you ever, logged in to something and it says like, welcome back, Barb, it's nice to see you, that kind of thing. And it sort of personalizes it. Okay, so we are going, like, the message is the same. The only thing that changes is the name that they use. So let's say name is the thing. That's going to be, we're going to need that in this function to greet someone personally so that we can say hello, and then whatever name gets passed in there, we're going to greet that particular person. Okay, so that gives us the keyword def, then the function name greet, and then the parameter is going to be presumably a string that contains a name is going to get passed in so that we can greet that person by name. And then we have to put the colon. And I'll hit enter. And notice what happens in the Python interpreter in interactive mode is that it tabs over and it's waiting for me to write statements that implement the greet function that I'm trying to make. Okay, so what I want to do is I'm going to print, welcome back, and then we'll put the person's name, and then maybe we want to put a exclamation point because we're very excited that they're here. Okay, so welcome back, and maybe we can say nice to see you. Oops, I need to put that in here. All right, so that will be my personalized greeting. And when I press enter, okay, notice that it's waiting for the next statement. So it's going to tab over again and wait for the next statement. Okay, and until I don't put any more statements there, it'll think that I can. So I could write 10 statements here for if I wanted to. But that's all I want to say. Okay, maybe that's a good enough greeting. And so as soon as I hit enter again on a blank line, it'll say, oh, the person is done writing that function definition, and it'll go back to this little interpreter prompt. Okay, and so now if I want to call my own homemade function, I just say greet, if I can spell it, and then in parentheses, I pass it a name. Okay, so let's say I want to greet Trey. It'll say, welcome back, Trey, nice to see you. Let's say I want to greet Amelia, if I can spell her name. Welcome back, Amelia, nice to see you. Okay, so I can pass many different arguments in there, and this is just like a generic greeting so that it can greet anything that I put in there. If I want to greet, okay, 1, 2, 3 as a string. It'll do that. Welcome back, 1, 2, 3. Nice to see you. Now that doesn't make any sense, but it's just taking whatever argument I'm passing in, and it's using that in place of the parameter called name. Okay, so notice I just passed in like strings that are constants, but I could also have a variable. So I could say something like person equals, and then Aiden as a name. And then I could say greet person. And then whatever value is assigned to person is getting passed in as an argument. That argument will get assigned to the parameter name and used here. So notice I don't have to use the word name here. I can use any other variable. These are completely independent. So person is a variable that exists outside of the function greet, and name is a parameter that is local here, and the value for person just gets copied into the parameter for name. It runs along, and if I notice, if I hear and I want to know what name is, and I say name, it'll say it's not defined. Okay, because it's only defined in the function. That's local to the function. The function isn't running right now, so name doesn't exist. It only exists when the function is running. Okay, so hopefully you get an idea. That was a very simple function, but and we'll write more complicated ones, but that's the way that they work. Okay, so that is an example of a function that just does something very simple. It has a parameter, but we also want to talk about return values, because often, you know, think about sine and cosine and square root, all the things in the math module, like those all return some kind of value. So, and often that's functions do something and return some kind of result. So your textbook distinguishes between two kinds of functions. Void functions, these are perform statements, but they don't produce a value. So really the greet function, like it doesn't produce any kind of value. For example, if I were to do something like value equals greet, and then I'll just greet myself. Okay, and then so it'll perform that. Now if I look at the type, it's just none, right? It doesn't return a value. Okay, so that's an example of a void function. It doesn't return any value. It doesn't produce any value. So print, or like what we just wrote, our greet function, where really all it's doing is printing things as well. It doesn't return anything. And then your book calls fruitful functions functions that perform some statements and they yield some kind of result that gets returned. And this would be more like how we do, if we call math.sign of 0, that's going to do something to figure out the sign of 0, and then it's going to return the answer so that we have a value that gets returned by that function call. And we can do the same thing. So if you want to write a function that returns something, in order to have your function produce a result, the last line of your function should be return, and then whatever value you want. Okay, as soon as Python sees the word return, it's going to exit your function and return and produce this value, whatever you put after the word return. Okay, so an example, like let's say we wanted to write a function that defined an average value. So it's not in the math library. There's no average in the math library. So maybe but we use it a lot. So maybe we want to write our own average function. So we could say define average, and we'll take in two numbers. Okay, and then we'll say answer is the sum of the two numbers divided by 2, and then we return that answer. So let's try that out. So let's come in here, we'll do def average, and then 2 parameters. Okay, we're going to just say answer equals the sum of A and B divided by 2, and then return answer. Okay, and notice after it saw return, it didn't give me a tab here because it's noticed that return. Okay, but I still have to hit enter again to get out of there. Okay, but it didn't tab over the same way it did in the previous, after the previous line. Okay, and so if I want to find an average now, okay, let me do, I'll just say, yeah, A. I'll just do num equals average, and then I can pass it two numbers. Let's see, I'll pass it the average of 3 and 5. And then if I look at num, it's 4. Okay. Now, one thing you might kind of wonder about is, okay, well, I passed it two integers, and the average value that it gave me was 4.0. Like, why didn't it give me an integer? So let's go back into the function and look. So I did pass in two integers. So if we come down here and look at this statement right here, we're going to have a plus b. That's two integers get added together, and we'll have an integer. And then we do an integer with floating point division and 2. So this single value here is floating point division. Okay, and so it's when it does floating point division, this returns a floating point value that it gets put into the number, into the parameter answer, or the variable answer, and answer is then going to be returned as a floating point value. So if you didn't want it to be a floating point value, then you would have to do something like to change the type there with one of your built-in functions. Of course, it's probably a good idea to have a floating point value as an average, because typically you're going to have, you don't always get perfectly nice integer averages. But I just wanted to explain why the type change there. Okay, so that is just a simple example. Now, as you can imagine, like typing these in when we're in interactive mode can get to be a little bit cumbersome. So I want to do an example with a script program. And we're just going to continue working on the program that we wrote for the last chapter that printed out the area and perimeter of a triangle. So we can put some functions in here and things that can make this a little nicer. Okay, so we're going to add some there. So the general flow of the program, we are going to want to initialize the values for the sides like we did up here. We're going to display some kind of a greeting that it just explains the program, and then it's going to calculate the perimeter and display it, and calculate the area and display it. So these are the main things that we want the program to do. Now, it's not important that somebody reading the program that has this part of it knows all the details of how this happens. And so we call this abstraction. All right, so these are the 4 things I want to do, and really I could just, I don't need to show all the details. Like for calculating the area, nobody cares that Heron's formula is what's used for the area. I just want to know, go off, calculate the area, tell me what it is, and I'm going to print it. Just like we don't really care how this square root function gets implemented or how the sine or cosine, like we don't care if they're using Newton's method or something like who knows what they're doing to compute the square root. We don't really care about that. We just want to know what the square root is. Okay, and so the same sort of philosophy, I guess, applies when you're writing a program. If you're giving it to somebody to read, they just sort of want to look at the main flow of the program, and they're only going to look at the details of how that stuff is done, if they have to change it or work with it in some way. All right, so let's open up the program. We have our triangle program here. this over here. All right, so the first thing that we want to do, we import the math library so that we can use it, and we're assigning some values to the sides of our triangles. That's our initializing the values. Okay, this is initializing the values for the sides of the triangles. The next thing that we want to do is display a greeting message. Okay, so down here, let's go ahead and put all of that in a function so that we can practice writing functions. So let's just call our function maybe display greeting. I'm having so much trouble spelling greeting today. Okay, and right now let's just not give any arguments to that. So we haven't really decided what it's going to do yet. I mean, I have some ideas, maybe you have some ideas, but we're going to display some kind of greeting. Okay, so that's going to be my call to display greeting. Now, one thing to notice is that a function has to be defined before it can be called. So in terms of writing a script, I don't want to go now and put, like, let's say I said, okay, well, I want to display a greeting, and I just need to find a place to put it. So let me put it down here. So I do def, and then display greeting. Okay, and then I just want to, display some kind of greeting message. So maybe I'm going to print, okay, this is triangle program version 1.2. And then, okay, this program will determine the perimeter and area of a given triangle. All right, so I'm just gonna, oops. All right, yeah. So let's say I have that. So I just wanted to display the greeting. I said how that greeting should look. So if I go and I try to run this, okay, let's look at what it said over here in this window, which is where the output will appear. So it tells me name error, name display greeting is not defined. And if I come over here, yes it is, it's right here. Okay, but it's very important that where you define it, that definition has to occur before you call it. So I called it here, and it's not getting defined until down here. So this, all of this implementation, let's cut this and move this. I'm just going to move it up here at the very beginning, okay, and I'm going to try to run it again. And this time it works just fine. Okay, so as long as it is defined before it's called, you're fine. So here it says triangle program version 1.2. This program will determine the perimeter and area of a given triangle. Perimeter is 21, area is 11.399, blah, 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 blah. Okay, and so sometimes I think it's nice to kind of, for your own sanity, to maybe put a little comment in here that helps. So you want your function definitions to come up here at the beginning so that you make sure that they're defined before they get called. So I often like to put a little, okay, note or a comment there so that anybody reading the program can see where it is. And then this right here, This is where your main, what we call the main program. So that's where that begins. Okay, so these up here, all my functions are going to be up here. Okay, this is not, so like if you were thinking about the interpreter and what it's going to do, it's going to say, oh, all this stuff up here, this is how you do, this is how I do functions. Okay, it's not actually going to execute any of that code until it gets called. It's not being called, it's just being defined here. Okay, where does it start execution? It starts execution at the first statement here. Okay, that's in our main program. So this will be the first thing that gets executed, the A equals 5, then B equals 6, then C equals 10, and then the interpreter will do display greeting. How do I display the greeting? Oh, I remember I saw that up here. It already knows how to display greeting because that was defined up here. So this down here is the code that's getting run. And then these are the functions that it uses and as whenever it comes across those function calls in the main program. Okay, so any of these function definitions up here are not automatically executed. They're only executed if there is a call to it in the main program. Okay, so we've now displayed our greeting. So this calculate and print perimeter, really, we should put all that perimeter stuff in a function. Okay, so we can up here do def, and then let's do perimeter. Okay, and then what do we need to calculate the perimeter? Well, we need 3 sides. So let's call our side 1, side 2, side 3. Okay, and then let's just have a local variable. Or we can even just do this in one statement if you want to. We can just say return, and then side 1 plus side 2 plus side 3. Okay. So, not rich run, but return. Notice it should show up orange. If it doesn't, that's a good indication that you've done something wrong. Okay, so one of the things that you can notice here is that you don't have to have just a single variable that you can return like we did in the previous one where we did answer equals and then did the work. So here it's just return and then anything that is a value. So it will first do side 1, side 2, so it'll find that sum, whatever value is equivalent to that expression, that is what value will get returned by the return statement. So some people like to do it this way just because it's shorter. Okay, and so when we come down here, all right, we don't need to do this. We don't have to calculate ourselves. We'll just call this print perimeter. That's really all we care about doing. We'll let something else. And so we can say print perimeter is, and then we can have a call here, and then we need to pass it to 3 sides of the triangle. So the arguments will be A and B and C. Okay, so this is a call to our function perimeter, which is defined up here. So whatever value is in the argument A will get copied into parameter side 1. Whatever value is in argument B will get copied into parameter side 2. Whatever value is in argument C will get copied into the parameter side 3. Okay, so A, B, and C don't exist inside this function. Okay, if I tried to say return A plus B plus C, it won't work. In fact, we can do that in a second after we run it and verify that the A and B and C don't exist inside this function. And similarly down here, we don't need to call these side 1, side 2, side 3. These names don't have to match up at all. These are just whatever values that I want to pass in for the perimeter. So let's try this and make sure that this works out. Okay. Oh, now down here I don't have anything called perimeter, so that's why I have trouble. Here, let me just replace this with a call to perimeter as well. Real quick. I mean, we might change some of this later, but just to get it to run. Okay. Okay, so it does the same thing as it did before. Okay, but now we're using a function to calculate the perimeter instead of putting it. So all of the implementation of how the perimeter is found is not part of the main program. We don't want to clutter the main program with all this extra work. We just want the main idea. I'm just going to show you the perimeter, and then down here, I'm going to replace the area with this in a similar way. Okay, so let's call this area, and again, I need side 1. I'm just going to call it S1, S2, and S3, just because there's lots of typing in here on this formula. Okay, and this one, it might be a good idea for me to do. So our S equals, I'm just going to copy this up here. Make sure this is tabbed. Okay, so S is now local to the function area. So S is half of the perimeter of the triangle. So that's going to call this perimeter function. Okay, and now I put A, B, C here. Well, let's just run this and see what happens. Maybe you can already figure it out. And then we're going to do area is, and now this time area is a function, not a variable, so I'm going to have to pass A, B, and C so it can do its work. Okay, let's just see what happens when we do this. Okay. So it says area is none. All right, that's not what we were expecting, is it? And so notice, okay, when we went up here, there was, first of all, no return statement. Okay. Let's say I do return area here. Oh, and I don't want to have this be the same. I should call this like capital A instead. I don't want to have it be the same as my function name. That's confusing. All right, let's try that. Okay, so 11, that's what we were expecting that time. Okay, so one thing to notice here is that these A, B, and C that are in the main program, these are called global. All right, so we're able to see them in this function, but really, we don't, that's not really what we are wanting to do. We're really wanting to use S1, S2, and S3 as our sides, not A, B, and C. We have to be a little bit careful because, you know, in this program here, the only variables are just these sides, and so it doesn't have any issues. But like, let's say I want to call this X, Y, Z as my sides, and then A, B, and C or something else. So like, these are something else that I'm using. Like, so let's make these, you know, 0, B equals 1, C equals -4. Okay, so maybe these are values that I'm using elsewhere in my program. Let's say it was bigger and doing more than this. Okay, and so if I pass that in, okay, and I run this now, math domain, oh, it's trying to take a square root of a negative number. All right, don't make that negative. Oh, this is not a valid triangle because 0, 1, and 4 don't make a valid triangle. Let's make this 2, 1, and 4. No, that's not a valid triangle either. Let's do 2, 5, and 4. Okay, so notice when I said area, and it's like, well, let me pass in. Let's say I wanted the area, and I put X and Y and Z in here. Okay, it doesn't change anything. Okay, so the first time, and I called my area function, okay, I put these numbers in, and it gave me the perimeter and the area of that function. Let's say now I want the area with using X, Y, and Z. So I want a perimeter with this triangle. Well, it's giving me the same old thing it gave me last time. Why? Well, because in this function, it's using A, B, and C. Okay, it's using these global variables from the main program instead of the parameters that I passed in. So if you want the function to work correctly, you need to use the parameters that get passed into the function. So we're going to use S1 and S2 and S3 here. Okay, this S is local, that's fine, but this A really needs to be S1 and S2 and S3. Okay, so let's try that now. Okay, and so we get now, when we pass in X, Y, and Z, we get the perimeter of 11. Is that correct? That should be 22. Let me see, perhaps. Do we need parentheses? Does it return before it ever gets the rest of that? No. Oh, because I still did perimeter with A, B, C. That's why. All right, so if I want the perimeter with X, Y, and Z, and the area with X, Y, and Z, and I run it that way, it's going to give me the perimeter of 21 and the area of 11. Okay, if I change these to A, B, C, and run it that way, okay, it's giving me the perimeter and the area for using ABC. So it only is, the output is determined solely by the arguments that get passed in and not by any kind of global variables. And that's what you want to do in your functions, is make sure that it's relying on the parameters that get passed in. Okay. So we have the main program. It assigns values to the sides of the triangle. We have two different triangles here. Let's just have X, Y, and Z be our, that's fine. I shouldn't, maybe, let me put these, no, rats. All right, I'm just gonna have to change these to X, Y, and Z. Okay, and here we don't need to know that Heron's formula is used. Let's just say print area. Who cares that Heron's formula is used? Okay. So we're going to print the perimeter, print the area. Okay. Where did our greeting go? I erased that too, apparently. Okay. Now up here, we should probably put some kind of documentation up here for area is that we're gonna use Heron's formula to calculate area of a triangle given its 3 side lengths. Let me put that on the next. Okay, so it would be good to put a comment up here by the area function. Okay, but that doesn't need to be down in the main program. So anybody that comes and looks at the program and tries to figure out what it's doing, they would just come and just read the main program. If they really cared about how the area or the perimeter were being calculated, then they could go look at them. But they don't really need to look at those to understand what it's doing. There's just initializing values, displaying a greeting, printing the perimeter, and printing the area. That's all we need to know. Okay. So that's how we could organize and write our program with functions. It's often a good idea, and I will do this probably every time when I write example programs, is put my function definitions at the top and my main program at the bottom, so things aren't getting all mixed up. It's a lot easier to read and find things that way. So it's a good idea for you to do that when you write programs as well. So try out a little program, maybe type this one, maybe you can try out some different things and get familiar with how Python works.